Well, good Monday morning to you. And we are going to be looking at common logs today. They're called common logs because they are common, right? So I'm going to write a common log for you, and you see if you can figure out how it's like the ones we've been studying and how it might be different. All right? So here we go. What if I wrote something that looks like this? Okay, so you look at that and decide, how is it different? Yeah, what's missing? The base. And because they are called common logs, the base is understood. Common means they are common. It also means, woohoo, we can use our calculators. If you look just to the left of the 7 button, you will see right here, log, okay? Log, log. And guess what? That's the base that we needed. But what I haven't told you, I don't think yet, is the base. So let's look. Log base, of 100. Frequently in math, we have some understoods. We have the understood multiplier, and that's 1. 1 times the log, 1x. And so we don't have to write the 1. It's an understood 1. 1 is the understood multiplier. 0 is the understood additive. So 3 is the same as 3 plus 0. I don't have to write plus 0. Same on a linear function. If it goes through the origin, y equals 3x, I don't have to write y equals 3x plus 0. So 0 is the understood addition. 1 is the understood multiplier. I wonder, what is the understood base on a log? Well, you can guess. It's base 10. Base 10. If you think about this, this makes sense. Our number system is base 10. Base 10 is the understood base. Now, good news. All of the properties that you learned about last week and the week before are still the same that we're going to use with base 10. What's the nice thing about using base 10? Well, it's base 10. So you'll be able to do a little bit of that. If some of you will be able to do a little bit of that in your head to help you understand it. If not, that's okay. We still got our calculator. But the second thing is, of course, since that's what our number system is based on, it is commonly used. And so I think that it will start to make sense. In science, science and math, the two bases that are dominant, that are used 99.9% of the time, are base 10, which we're going to learn about, use today. There's nothing new to learn. It's just using it and getting used to not seeing the base written. That's going to be the new part. And then the second one is base E, which we will look at Wednesday and Friday. All right? So log of 100. So I will put in a base B right here, okay, to kind of help you think about it just for now. Log base B of 100 equals, all right? But know what? That is base 10. So let's just go ahead and put the 10 there. Now let's rewrite that. We don't know what that is, okay? So let's say x. So let's rewrite it in exponential form. And how do we do that? Well, base raised to the exponent equals the argument. And guess what? Oh, now your brain's jumping to it, isn't it? Because you know it's base in base 10. What do you raise 10 to get 100? Well, it's 2. So that's what this is saying. Log of 100 is 2. How many times do you multiply 10 by itself to get 100? What is the exponent? What exponent do you raise 10 to get 100? Oh, 2. So log of 1,000 then is 3. Log of 10,000 is 4. Log of 1,000,000 is 6. So if you think about what exponent do I raise it to? 10 to the 6 is 1,000,000, right? 10 to the 9 is 1,000,000,000. 10 to the second is 100. Excuse me. So this, though, this 10 base is going to be understood. You're not going to see it written. So just remembering, oh, it's not there, it's base 10. And again, those of you that go on and do advanced science and math or do advanced science outside of high school, those of you especially that want to do science or medicine will be using logs when you do all of your wild and crazy chemistries. Okay. So let's just do a couple of examples on this. Just a couple using our calculator, and then we'll go on and do some solving with this. So you can just essentially, you can see what it is, like log of 5, and it will be written like that, log of 5. And it is understood to be base 10. This one is not a whole number, so you don't know what this one is. 10 to the what is 5? Oh, well, 10 divided by 2 is 5, but 10 to what power is 5? Well, that's going to be a number less than 1, right? So now, dun, da, 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 we get to use our handy dandy calculators. So you're simply going to turn it on and push my battery is low. Thank you. I will charge it. So you're going to say log of, and then just put the number 5 and close the parentheses so your calculator knows that the argument is finished. So log of 5, enter, and I get this lovely decimal. All right. We are going to take that to 5 places past the decimal, 5. All right. So mine says 69897000043, but I'm going to do the little wavy approximate, all right? And it's going to be 0.69897, right? And then, of course, that's rounded. So we've got zeros and then some other numbers, which just means what? If I took 10 and raised it to the 0.69897 power, I would get approximately 5. And those are common logs for which you will be grateful to use your calculator. Okay, so that's our introduction. In the next example, I will do some solving, and then I'll show you how you can actually change the base on any log to a convenient base, which of course for us with calculators will be base 10.